Alejandro, we give you the warmest welcome, Alejandro Noguera. He's our last panelist. He is original business development manager for the region, excluding Brazil, the by SAF batteries. SAF batteries have different development areas in the scope of storage in the industrial area, industrial sector, and of course a sector targeted to transmission and distribution. He's responsible for the stationary division of SAF. He's in Chile, 13 years of experience. He, on his behalf, on the sector of quality and energy backup with big multinational companies. He's electrical engineer from the Simon Bolivar University and MBA from the Westminster University, UK. Welcome, Alejandro. We've got about 15 minutes for your presentation. Thank you. Okay, first of all, thank you for the opportunity and that in general for all the great team and for Felipe. I'm completely aware I'm the last constraint between all of us and lunch. I'm going to be brief in my presentation. And many of the topics I wanted to cover have already been touched more or less. Well, the purpose of my presentation today is coming back to the basics, coming back to the concepts. We've talked about battery storage systems. We've talked about technologies of what can comprise batteries. My purpose today in these 15 minutes is talking about the basics concepts of the different electrochemical alternatives available in the market for us to have the same tools when making decisions in regarding this topic. Very briefly, initially, I'm going to talk about me, the company I represent. I work for the Saft company, a multinational company with headquarters in France, with more than 100 years with more than 100 years of history. Our headquarters are still in Paris. We are focused in electrochemical energy storage or batteries. We work with electrochemical cells, metal and lithium ion and some others. From 2016, this company was open to or was listed in the stock exchange in Paris, and in 2016 we started being part of the total group that acquire 90% of the share. We've got 16 manufacturing facilities. Most of them are in the US, in particular also in Europe, and some in the Asian market, but only for the Asian market. We have presence in 19 countries with more or less 4,000 employees. What we do, as in the presentation says, we energize the world on land, at the sea, in the air, and in the space. We do this through the 5 divisions conforming us. I represent in particular the ISB, the standby, which is in charge of the backup energy storage systems. We've got some responsibility for transportation and mobility, railway transportation across the region, and there are also other divisions that is division for great technologies. For instance, in lithium, this is technology that it is trendy for some time. We've been 20 years launching lithium to the space, and we feel very proud about that. Then we have the connected energy division that goes a little beyond in smart metering and electronic toll collection. Then we've got mobility. In mobility, we're in charge of aviation, terrestrial transportation, or railway transportation, and 80% of the fleet of airplanes have internally soft batteries. And ESS is about the topic we've talked about during the morning, which is energy storage systems. What in fact, these are storage systems for power applications where the lithium battery is the starring. And why is it the starring? Because of what I'm going to talk about later. Then we've talked about during the morning that the market of energy storage is increasing. There's a need and there's market demand for these kind of solutions. At the beginning, technologies at electrochemical level, battery level, because we are in the terrain of the storage energy, but what kind of the best, and we are going to see what kind of batteries Mr. Best invented, and today is the lithium ion from some features we are going to mention, and of course there are lead acid batteries and other kind of batteries. There are redox or batteries, are other kind of technologies, which is also getting momentum. But how to define, in fact, or how to determine what kind of batteries or what kind of cell to use on each of the applications? Well, it will depend upon a lot of the needs of my project. In fact, as it was mentioned in several presentations, it's going to depend upon what purpose I'm going to use the battery storage system for. It's not the same how many battery storage systems for RAM control or for peak shaving or shifting. We can see at electrochemical level there are important differences on the power density and the energy density they may provide each of these electrochemical combinations. Supercapacitors, we can say initially, they have great capacity of providing power. Nevertheless, these are not a good solution for solutions that require a long time for charging. Even the lithium world, we can see different kinds of cells. We can see high energy cells or for medium power and for very high power or ultra high power. The message beneath is not that it's a good or bad battery. There are different applications, and the important is to make a decision to determine which is the best suitable to the needs of the project. I'm going to initially start with the most well-known technology, which is the lead acid battery. We all know the most basic model of the battery, which is a cathode plus an electrolyte. Anode cathode in the lead acid, the plates are two lead alloys with sulfuric acid. This is an extremely well-known battery that is plenty available in market, in particular in the market of mobility and the automotive. It has a very low production cost. The capex level, they have a great advantage that many kinds, and it could be introduced in different. It could be a lead acid in tubular. It could be a flat battery. It could be from different alloys, as I mentioned, plum antimonium, plum selenium, lead calcium. The electrolyte could be liquid, could be in gel. It could be solid electrolyte. It could be horizontal installation. There's a plenty availability of solution of products that in fact are going to be targeted for different kinds of applications. These if I want a deep discharge cycle, but I don't want a deep cycle, but I need more resistance for temperature, for instance. But in fact, in terms of recycling, the they have a lot of alternatives that many people need lead for this kind of batteries, and lead is used as a raw material. It tends to be a good business in terms of recycling. But if we go to the disadvantages, having good network of recycling, it doesn't mean that the pollution level is low. This is a heavy metal lead, and they have a number, they require a number of things for production. In fact, if that lead, the reusage of that lead is not well used, the environmental footprint could be quite high. The other main problem of lead, of the lead acid battery, it was born as a problem. Is I put a rod of lead in sulfuric acid, that sulfuric acid is going to erode part of the material, that at the end of the day I will lose part of the plate, and it starts corroding because of the electrolyte. I'm going to reach a point that simply I will have an open circuit because there is not enough material to interact with the electrolyte. This is what is called the sudden death that today I've got autonomy, high capacity, but in the tomorrow I suddenly my car doesn't start because the battery is burnt out. This robustness because temperature becomes wear or corrosion to speed up, and the battery this wears faster and has to be in a controlled environment. Of course, has other kind of failures. It has, but this is a battery that is designed more or less for applications which are not critical and for easy maintenance because it doesn't require high maintenance. To know how much material has been eroded in the plates, I will have to know where it's the moment to change the battery or not. Moving a little bit more, it's a nickel cadmium battery. In fact, the model is more or less the same, but metals change. What is nickel, cadmium, and uh, in cadmium oxide, in the alkaline is potassium oxide, and plates are formed by stainless steel, and the active matter, which is nickel cadmium, is encapsulated in let's say between two stainless steel plates. They're accumulated one side and the other, and in a frame. We can see here there is no chemical reaction of wearing between the electrolyte and the plate. The structure of the plate itself is not committed for the lifespan of the battery. It has a very long lifespan, 20 to 25 years. The customers, for instance, in Metro Santiago, they have nickel cadmium batteries working for 30 years or more. And this is precisely because the integrity of the plate in particular is not committed in time as it is in a lead acid battery. It is quite mature technology. Soft have been selling nickel cadmium batteries for years, and we've got customers all across the regions with many applications that are it's a proven technology that has provided maturity and great reliability a long time. It is a battery that usually requires little maintenance. That it is that is what it is called free maintenance, badly called. In fact, it is a battery when it occurs it's wearing. I don't have to be on top of it, when I'm on top of it, in order to find out how much material is remaining from the plates. It may work very well over 20 Celsius degrees and is less susceptible to temperature change. It is important for every battery, the temperature changes, but it's more resilient. For instance, working at 40 Celsius degrees, I still can get more than 70% of its normal capacity. The problem of nickel cadmium, if the investment cost, the capex, although the lifespan of the battery is, it makes the total cost of ownership lower. This is a higher investment. And well, in fact, if we only see the initial investments and we don't see the full history of the cost of the solution a long time, it tends to be it tends to have a disadvantage compared to the more traditional batteries of lead acid. The other is recycling cadmium or nickel cadmium. They have great levels of efficiency. There are not too many recycling facilities because there are not too many manufacturers of nickel cadmium around the world. But we as manufacturers, we are demanded to recycle to recycle as much as possible. We have our own plants, but in particular in this region, there is not an extensive grid, and there's a point that in fact you have room for battery of this kind of batteries to be less attractive. Then we've got lithium ion battery or light ion batteries that because of different conversations that came already mentioned, one of these kind, we have an umbrella concept. There are many lithium ion batteries, and we have as well as we have different lead alloys, and there are with different features that produce with different metals. We are going to see in the presentation this cobaltum oxide, the magnesium oxide, and the cathode. These are the most common electrochemical batteries. In the case of the anode, almost all of them use the same graphite. There are certain anodes which are under development, such as the titanate oxide, and the next anodes, they're still very expensive, and there's still time for them to reach the market. Each of these electrochemical combinations have different behaviors. We can see that see they have great NC and MC have great energy density, but they have a lower behavior compared to other electrochemical solutions, and that's why in the applications are clearly different in different solutions. Industrial, of course, in fact, we have uh, NMC and with iron oxide. There are many of them. They work with all these electrochemical solutions. Nevertheless, they choose the best suitable, having the different solutions supplied. For instance, for UPS in a data center, we use an iron for that, but a 28-volt solution, we used another. Why? Because each of these electrochemical solutions, they have different features, independent features. We can say, for instance, that MC and NSA have a great power density, a great energy density, but at safety level, they tend to have they have to fail a little bit. But it's the contrary. In the iron photide is the most stable and the safest electrochemical. When there's a catastrophic failure in a cell, there's a gas explosion at temperature level. In the case of the iron phosphate in particular, it is first more difficult to reach that condition, and gases expelled from that cell, and they tend to have at much lower temperature than the other electrochemical combinations. They could be also mixed. There are batteries that iron phosphide. There's mixtures between manganese oxide and aluminum phosphate or aluminum oxide. But it is important in this slide at this point, but when comparing lithium ion batteries, you have to understand and you request information on what kind of electrochemical solution is being used in that battery, because not all of them are the same. Each of them have the features, advantages, and disadvantages, as many things in life. The main advantages of lithium ion: great energy density compared to a lead acid battery. A lithium ion battery may mean 80% space saving and a very more than 80% weight saving. They are very light batteries. They have a 3 or 4 times more recycling capacity compared to a traditional battery. It is used in mass consumption, computers, laptop computers, watches, etc. That it is a very efficient battery. It was being mentioned in this presentation, which is also very important, in particular for mobility projects that place a lot with fuel saving, and the less I have to charge the battery, the most savings. This is a battery with not heavy metals inside. The number of metals is very low. Nevertheless, this is a technology that is required to be improved in the recycling networks equally. It's being talked a lot about the second life of a lithium ion battery, of recycling many of the components, but still we have to mature this kind of batteries. But I have no questions that at a moment it's going to arrive that, because it's being massified because of electromobility and using these kind of batteries in the industrial systems. They have an advantage that the capsid is you have a cell that the is lithium ion tubular shape is lost. They generate positive and negative at the same time, and the need of having power electronics, having the need of control, it gets the advantage that generates a smart battery. You can see this state of charge, the lifespan of the battery, temperature, etc. But a robustness, when introducing electronics, it has a disadvantage in terms of usage compared to a lead acid battery. In a city card, is very economic, takes you from point A, point B, but it's not as robust. Nickel cadmium is a water tank. I can take it wherever I want. It's expensive and heavy. Lithium ion is smart, is lightweight, but it also has computers and electronics associated that makes it a little bit more delicate, and it has more failures. The most kind of failures is not in the cell in particular, but in the control of that charge and discharge cycle on this lithium ion, because that electronic system is a little computer, and the lithium battery has the particularity that it's not naturally balanced among them. If I put one cell which is a little more uh, charged than the other, the most charge is going to overcharge, while the other is, we have to have some smart component that coordinates the balance between all cells, and in fact to have the harmony in across the system, and the charge in the night in the day and discharge in the night has to be a controlled action. These are lithium, there are many batteries well known, and there are other technologies, in particular solid state lithium batteries, and the electrolyte is a polymer that has a lot of advantage at density level and safety level. In a couple of years we are going to see these kind of batteries at commercial level. This is something important. We've also talked about we've seen metal air, but they have a higher energy density. Resources of the air are quite abundant. Similar occurs with the graphene batteries. Then we have sulfur, we have a little bit more safety. We have sodium ion batteries. They also have good projection to what we see in the future. Nevertheless, there's a weight issue. These are a little bit heavier than lithium ion, and they require different spaces. And when we have redox, which is a recirculating liquid, that tanks are required with certain dimensions and densities which are different. At application level, we've already commented this today with plenty of details. I'm not going to spend a lot of time at this, but along the production change at energy level, we could use batteries for storage, whether stationary or dynamic. In the stationary or on standby, these are batteries I mentioned are flotation batteries waiting for perturbation, but I can provide backup as backup energy, such as a UPS. Then we're talking about dynamic system of energy storage when we're talking about storage distribution. The different technologies that to start gensets, not only using lead acid batteries as usually known, and everything related to communications safety. Just to mention, the last list have been already mentioned in many presentations, but the main applications of these technologies in the generation, it could be what kind of cell to use, focused on power or energy in RAM management, in a power oriented battery delivering a lot of energy in little time, and we may filter that rectification of the curve of relation of renewable energies. Then I combine a little bit mixed. I combine power required to solve the heterogeneity and also energy flow to reach a point for preset forecast shifting. Of course, is quite easy. I just stored our generation and I deliver the generation in a different time compared to the time I generated, and I could be then at grid level, we've got frequency control, peak shaving, and at meter level, there might be many applications. We've talked about that during the whole morning. I'm not going to repeat that, but these are very interesting applications. Just to wrap up, I've got a couple of examples to show you about solutions that have been implemented at energy storage systems. In this case, is in Bolivia, in a remote area called Cobija. There was a hybrid project. If I'm not wrong, this was 2018 or 2019. In fact, they combined PV plus diesel generation, and And in diesel generation, that we have a set of batteries to maximize the PV penetration and maximize the usage of the energy. In a similar case, we've got in Australia a mine used, it combines wind generation, PV generation, and batteries. In this case, the purpose was to maximize the use of renewable energies, to reduce the environmental footprint, to decrease the use of the fuel, and generating economic savings. And finally, a little video about the project.
Entonces, bueno, eso era lo que quería conversarles con ustedes el día de hoy.
That's what I wanted to talk to you today. Thank you very much for your time and for the opportunity. I'm going to leave the floor to Felipe for closing the module and for the Q&A session. Thank you, Alejandro. Thank you for showing us the different technologies available around batteries. Certainly, behind each of them, there's a world of research and applications for each of the schemes, working schemes. It is important to take in mind all of that. I would like to invite you and invite Patrick and Mr. Josh to turn your cameras on to briefly share a few questions. It is 5 to 2 o'clock approximately. Apart, we've got Alejandro McDonald. I don't know if you're there, Alejandro. Perfect.
Muchas gracias a cada uno de ustedes por sus fantásticas
Thank you,
presentaciones.
each of you, for your fantastic presentations. I'd like to ask a question to Professor Mr. Josh.
And probably we can all discuss it around this.
Mr. Josh, or Professor Jessa.
Geza, yes.
Canada, a lovely country that I like to be there frequently, actually, is quite similar in terms of water resources, and you also have a very large interconnected system. Chile is a long and thin country, and you have developed this working group around batteries, but you also have seen different kind of technologies. So what would you recommend to a country of Chile, considering the wide variety of technologies? Yes, that's a general question.
So it depends upon your constraints. Canada has no issue with power generation. A number of provinces have mostly hydro, and so they have a significant amount of resources. So Quebec is 100% hydro, British Columbia is 100% hydro, Manitoba is 100% hydro, and the other provinces of Saskatchewan and Alberta are burning coal and oil mostly, and they're developing wind farms. The problem, or they don't have an issue at the time, because the wind penetration is very low, and there's no solar because we're a northern country. The wind penetration in Quebec does not exceed 10% and will never exceed 10%. It's a government regulation. In other provinces, the penetration is low. So there is no issue of balancing. And if there is an issue of balancing, it's done using hydro, at least in Quebec. So there is no need at this time for solutions that will help accommodate wind and particularly solar. Wind is not too bad because if you build them high, the power generation is more or less constant. The variations are very small. And there are provinces, places where wind blows more at night than during the day. So the daily variations are not significant. So batteries, there's no business case for batteries at this time, except in remote communities. So in remote communities, what we're trying to do is deploy solar and wind in combination. In some mining sites, they develop wind and battery, wind and storage. But that's about it. There is no big deployment of battery energy storage at this time. The rest of it in the US, it depends very much upon the state. And the state that has the biggest problem is California. And that's where you have the biggest deployment of battery energy storage system and solar. But the rest of it, again, there's a lot of baseload generation that is coal, that is gas, and that is nuclear. So we don't have a problem at this time, and we don't have the problem of hydro going away yet, like you have. Unless there's a big climate change and the rivers dry up, we won't have a problem. And the population doesn't increase that fast, and the load is decreasing. So we can do with the infrastructure we have at this time.
So we hope we contribute to this experience of your working group as well.
Yes. Well, this is why you have to basically make a business case. That's what I was arguing all along, because it's an expensive technology. It is a technology that we don't know the life expectancy of. So you have to consider all of these elements in it. It's very complex. You look at the presentations that were made, and this is why technologies like pump storage is still of interest. Although there is a caveat there. In Canada, somebody tried to build pump storage deep in a mine. And the idea was shut down because people said that if there is a failure of the hydro system, the bottom of the mine where you have your pumps gets flooded and the whole equipment gets destroyed. The pressures are horrendous. So that's because somebody tried the gigawatt. Because you don't need, if you have a kilometer or 2 kilometers of height, the problem is the pressure at the bottom.
I see.
So unless you do it by stages, I don't know if that's feasible, but then it becomes extremely expensive.
Well, then, coming to the experience of the other panelist, probablemente, Patrick, tú podrías contarnos acerca
Maybe, Patrick, you can tell us about your experience and the applications, probably more natural applications in what means storage with the pump systems, and both Alejandro, and maybe Alejandro Lovera, Alejandro McDonald, and a certain rank of approach in their different activities can tell us from their side about the more frequent applications that you see here and what problems you've had to face. Patrick? Well, in fact, we were seeing at we're seeing a return in the pump storage project, especially in Europe and countries very particular countries such as North Africa and the Middle East, which are quite similar to northern Chile. And we're implementing large capacities and then wind and solar projects. And they are changing the decarbonizing their energy matrix as let's just say like in Dubai, Oman, and all of northern Africa. And we're also seeing the very same in Central Europe, where there's another push, especially with the interconnections. Germany is building the large HVDC lines, and in Austria and Switzerland, they're building the batteries basically. And it is a development that we're working on now that we're seeing it, and we're also seeing a modernization of existing centrals and projects where sometimes they are changing normal units, traditional units for generation with reversible units precisely to aim to the flexibility and then provide complementary services for the transmission network. And the same things happening in Latin America. We started with the first projects in 2014, I believe. Was one in Mexico, another one in Peru, inside a mine. And in Chile, we also have several projects being evaluated. And everything is going together with the development of renewable energies. And when I got to Chile in 2015, and I saw the portfolio of solar projects, I said that at some point here, we needed to consider storage. And here we are. We have a rather strong career with a large commitment. And Alejandro, one of you, both Alejandros, how do you see the applications precisely for batteries in this case? If you want, I can start. Well, what we are seeing mainly in the applications are for arbitration, energy shifting, and complementary services and capacities, and contributions for capacities in the system. And what we are seeing in the world is that these systems are increasing. So today's systems have several hundreds of thousands of megawatts of storage per hour. And what we believe and what we are seeing is that the capacity for the battery storage systems of having multiple applications and to be able to execute several applications at the same time with the same system as shown in the presentation of so what we can the system that is participating in the capacity market is doing, participating in the complementary services and reserve some energy for the shifting if given the opportunities. So that versatility of the system is what we are seeing that our clients value and value in great magnitude. So the other thing is the flexibility of being able to change from one business model to another with the same system. So if today the market migrates and values the specific service better, having a tool that's powerful enough in order to provide this type of service, it's very valued in the market. For example, what was shown for the gas in Pomona, that system was built for 20 mega to 80 megawatts per hour with 4 hours of capacity. That was built mainly to address gas cuts that that has stopped in the market and were very high. So it was built for capacity mainly, to present capacity, and today it is involving other businesses, complementary services, businesses. And this flexibility of being able to evolve to different business models is something that we see as very important. Thank you. Well, Alejandro, so how do you see it? Well, from my side, I'm in different areas, and of course, this market, what they're seeing, these are solutions that are quite critical, and there's certain difficulties for the global aspects that we're seeing now, and that leads us to these remote areas and the transmission and then the working systems. And for this case, for the dynamic station, and as Professor Isa said, and Josh said, we need to make sense of the different solutions, since we're not just competing against different energies, but we also want to reduce emissions. And of course, that also makes that it's much more viable economically. So it's a trend to fight the cost of energy, but there's also important growths to consider. And currently, from this perspective, the projects that make the most sense are these mediation systems. Well, there's a good feedback from each one of you, and we want to thank you specifically for participation and contribution. And we hope that Professor Isa can understand my thank you words in Spanish, otherwise it's translation.
That's fine.
Are you being translated?
I tried to.
Felipe,
The
está
only
siendo
thing is
traducido.
that.
Okay, gracias Manuel.
Thank you very much for inviting me, and I do appreciate. And we should be back in Chile sometime, roaming Patagonia and places, faraway places. The only places left in the world, like Iceland, that very few people actually live in and do tourism in. So it's very enjoyable.
Thank you very much for your presentation, Professor. Muchas gracias a cada uno de ustedes, Patrick,
So
Alejandro.
thank you so much, every one of them, Patrick, Alejandro, for all your contributions in the name of SIGRE. And Alfredo, thank you as well, and all the SIGRE support, and for this introduction, of course, Manuel and his team. So we now give you the rest of the seminar.
Alfredo. ¿Sí?
Alfredo.
Muchas gracias a todos.
Thank you so much, everyone. Alfredo? Oh, I was muted, it seems.
Adelante, Alfredo.
Go ahead, Alfredo. All right, so thank you very much for previous words. I was muted, sorry. And I want to thank the other panelists and Dr. Isa. Thank you so much for your participation, for your contribution. And tomorrow we will have another day, and with very important panelists, very important presentations. And as mentioned today, we want to celebrate and talk about everything related to storage systems, and we will address more briefly the green hydrogen and challenges and opportunities presented by this concept. So thank you very much, everyone, for being connected, for your questions, for your participation and your interest. See you tomorrow.
Hasta mañana. Muchas
Somos
gracias.
Transelec.
See you tomorrow. Thank you.
Más de 500 personas. personas y más de 70 años de historia como protagonistas del progreso de Chile. En la década de los 90, cruzamos el canal de Chacao por primera vez. En 2012, finalizamos con éxito la línea Maitencillo-Caserones a más de 4.000 metros de altura. En 2018, pusimos en servicio el primer túnel en alta tensión del Sistema Eléctrico Nacional. Hoy, estamos reforzando el sistema con obras en el norte y el sur del país para hacerlo más robusto y posibilitar la conexión de energías renovables y avanzar así hacia la descarbonización de la matriz energética. Ponemos al centro nuestro compromiso de desarrollo sostenible y de responsabilidad con las comunidades vecinas, buscando siempre construir relaciones de confianza. Con casi 10.000 kilómetros de líneas y más de 60 subestaciones de Arica a Chiloé, somos Transelec, la principal empresa de transmisión del país. Transelec, uniendo a Chile con energía.
We all have something in common. We live on this planet, and this planet gives us life, a journey to fulfill, a future, and we all began that journey somewhere. For Hitachi and ABB Power Grids, our legacies are interlinked. From our humble beginnings in the copper mine industry over 100 years ago, both companies have grown globally, diversifying our lines of business, and both contributing to society with new technologies. This is the power that brought us together. And together, we can reduce our impact on the planet by bringing sustainable energy to more people. The challenge is laid out before us. It requires the vision to foresee a stronger, smarter, and greener grid. and the dedication to increase quality of life through digital innovation. Bringing social innovation to every corner of the globe. To make this happen, we advance collaborative creation with our customers, academics, and governments. Together, we can encourage the next innovation. Only through co-creation and cutting-edge digital solutions can we create new customer values to make life on this planet better for everyone. Together, powering good for sustainable energy.
Corpa es ingeniería de vanguardia en transformadores de poder. Aseguramos la confianza y la operación continua de los equipos eléctricos, brindando un servicio completo de mantenimiento, montaje, reparación, asesoría e inspección para transformadores de poder y equipos eléctricos. Estamos comprometidos en el mejoramiento continuo de nuestro sistema integrado de gestión, logrando la satisfacción de nuestros clientes a través de un servicio integral, eficiente y eficaz. Visítenos en www.jorpa.cl.